In this video, I'll be explaining the mean value theorem, what it means, and why it's useful. The mean value theorem says that if we have a function f, which is continuous on some closed interval a to b, then there exists some number c on that interval such that f of b minus f of a over b minus a is equal to the derivative at some point c. Now what is that saying though? Look at the term f of b minus f of a over b minus a. Do you recognize it? Well, what if I wrote it like this? y2 minus y1 over x2 minus x1. That's the slope formula. So essentially, this theorem is saying that if we have a function that behaves nicely, the slope over the whole interval is going to be the same as the derivative or slope of a tangent line at least one point on that interval. Think of it this way. Say you were a bird flying from Washington Square Park up to the Empire State Building. Since the Empire State Building is directly up Fifth Avenue from the park, the shortest distance is just right up Fifth Avenue. But notice that if you take any other path up to the Empire State Building, that at least one point on your path, you will be parallel to Fifth Avenue. That's the mean value theorem. Just think of the shortest path as the left side of the equation, and the point along your path where you're in parallel as the right-hand side. Let's look at a quick example. F of x equals x squared minus 5x plus 7 on the interval -1 to 3. Let's check the left-hand side of our equation. F of b minus f of a over b minus a. Now in this case, the lower side of our interval is going to be our a, and the right-hand side of our interval is going to be our b. So f of b, plugging in 3 into our equation, we get 3 squared, or 9, minus 5 times 3, so minus 15, plus 7, minus f of a, plugging in -1 into our equation, -1 squared, which is 1, minus 5 times -1, or plus 5, plus 7, over b, or 3, minus a, or -1. 9 minus 15 plus 7 becomes 1, minus 1 plus 5, or 6, plus 7 is 13, over 3 plus 1, which becomes -12 over 4, or -3. So now we want to know, is there some point where the derivative of this function is equal to -3? So let's check the derivative. F prime of x. By power rule, x squared becomes 2x. -5, bringing down the constant, we get -5, and constants just drop off when we take the derivative. So we get the derivative is 2x minus 5. Now we want to see, is there some x value where that is equal to -3? Bringing over the 5, we get 2x is equal to 2, and dividing both sides by 2, we get x is equal to 1. Which means that 1 is now our c that satisfies the mean value theorem, if -1 and 3 are our a and b, and this is our function. The mean value theorem is important mostly when we're trying to find maxes and mins. Specifically, if there are two different x values, a and b, that have the same y value, then in this case, f of b minus f of a would be equal to 0. Then if we had a function going through those points, maybe something that looks like this, then somewhere on that interval, there must be a c where the derivative is equal to 0. In this case, it's right up here, which makes our c right down here. And that gives us a local max because this function is concave down. If our function was concave up, we would get a local min. Hopefully that cleared some things up.